So when looking at permanent charge by induction, the charged object will always take on the opposite of the charged object you are bringing near it. So for example, if I have a neutral pith ball and I do a permanent charge by induction by a negative rod, the pith ball will become positive. Because remember, electrons will want to leave the pith ball because they are repelled by the negative rod. So there'll be less electrons than when it started out. A positive rod, if you're using a positive rod on a neutral pith ball, at the end of that permanent induction, the pith ball will be negative because remember, electrons will actually move into the pith ball because they are attracted to that rod. So the final charge that you are creating will always be the opposite of whatever rod you are using to do it with. So here is a look at that permanent charge by induction using a negative rod. So here we have an electroscope. So the electrons here are being repelled by the electroscope. They're being repelled by this negative rod. So all the electrons are kind of hanging out down here at the bottom. So right now, if you were to remove this rod, this would be temporary. But we are going to now add in a ground. So see how now this person's hand is acting like a ground. So the electrons are leaving this electroscope because they are repelled by this negative rod. So once we remove those, the overall final charge on this is going to be positive because electrons have actually left the electroscope. So it started off as being neutral, electrons left the electroscope, and we now have a positive charge, right? So what's different between this and any other type of charging we've seen is there is no actual direct contact between this rod and this electroscope. We're using the charge on this rod to force those electrons to actually leave. So taking a look at when we want to create a negative charge. So notice here we have a positive rod and a neutral electroscope. So in this case, the electrons are attracted to this positive rod. So notice there are no electrons hanging out at the bottom. They are moving up here towards this positive rod. So right now, if you were to take away this rod, this would go back to being neutral. But if we add in a ground, the electrons will actually move into the electroscope because this positive rod, remember, is attracting electrons. Opposites attract. So once we remove the rod and the ground, we end up having a negative charge here because electrons have come in. So we started off neutral. We use this positive rod to attract electrons in, which caused a negative overall charge once the induction is complete. So remember, if you do not include that ground, if you remove the rod, this would simply going back to being neutral. It would be a temporary charge only. Okay, now I'm going to attach on D12 a few different simulators and videos to help you watch this concept and kind of play around with it again, because it's kind of hard to see unless you actually look at the movement of electrons. Okay, so this last page here is a summary of all the charging types that we've looked at in static electricity. So we had charge by friction, charge by contact or conduction, same thing. We had induction temporary, and then induction permanent with grounding. So let's take a look. So friction, we start off with both objects being neutral. The initial charges are neutral. Is there contact? Yes. So friction, there is rubbing, right? So you're rubbing one object with another. So the charge after you have friction occurring is permanent, and they are opposite. So one object will become positive, the other object will become negative because electrons are lost from one item and gained in another. Charge by contact. You start with one neutral object and one object that has a charge. Yes, there is touching, so this is simply a touch. So electrons will essentially jump from one object to another. So whatever object it is that you touched it with, The same charge is what the object that was neutral will become. So if we touch this with a positive rod, the neutral object will become positive. If we touch the object with a negative rod, the neutral object will become negative, right? They will become the same. Charge by induction temporary. You start with one object with a charge and one object that is neutral. There is no contact between them. So it is a temporary charge, and when the objects are removed from each other, it goes back to being neutral. So think of the balloon with the wall. You bring the balloon close by, the wall is still neutral if you remove the balloon again. Induction with grounding attached, which creates a permanent charge. You again start with one object charged and one object that is neutral. There is no contact between the objects. However, because of the ground, we now create a permanent charge, and they are the opposite. If you use a negative rod, the object will become positive. If you use a positive rod, the object will become negative, depending on if electrons are coming in or moving out of the ground. Okay, so please make sure that you watch the videos and all of the links that I'm going to share with you. I find it much easier to see and understand the differences between these when you look at them in motion. Okay, so this is going to be the end of our static electricity portion. Our next lesson in electricity will be starting to look at current and looking at circuits.